Hello, everyone, and welcome to the second episode of REHAU Academy On-air for Season 2. So this is a new podcast series that we're bringing back this year to have more conversational kind of topics, discussions about different products and applications. Today, we are going to talk about pre-insulated PExa piping with Kevin Hale. So to start with, my name is Max Rohr. I'm the Marketing and Academy Manager for REHAU based in Leesburg, Virginia. I like to say that I teach people to move energy well with water. I've grown up in the industry. I love hydronics. I love hot water heating and cooling. Buildings are an enormous part of the energy use that we have in the United States. And we in the wet side of the heat industry and hydronics, we know how to do that really well. Water is a great vessel for BTUs. And in this course, we're going to kind of discuss some of the ways that you can do that with PExa energy transfer pipe. And my co-host today is Kevin Hale. So he is a business development manager with REHAU based in Colorado Springs, consultant, educator, and problem solver. Kevin, do you want to tell us a little bit more about yourself?
Yeah, sure, Max. Thanks. My name's Kevin. I live in Colorado. Before being a REHAU guy, I was a wholesaler for a couple years and got a good background there, and that helps me kind of translate that into kind of big picture plumbing and heating stuff in my REHAU capacity. I've been with REHAU now going on, this is my 12th year. I'm a territory manager now. I cover areas in Idaho, Utah, and Arizona, and before that I was our program manager for this INSULPEX product that we'll talk about today.
And that's part of the reason that we wanted to have you co-host today is that you've worked on a bunch of cool projects in kind of the Mountain West territory, but you've really had your hands on projects all across North America. So you've got a great background for the different applications that we'll talk about today. Okay, so for the agenda, we're going to talk about the pipe itself, the applications and benefits, go through some projects, and then have plenty of time for questions. So if you want to submit a question, you can type that in with the little question chat box that is on the side of your GoToWebinar interface, and we'll answer some of those as we go, and then we'll also wrap up all the questions at the end, so we'll leave some time there. Okay, to start with, Kevin, do you want to tell us just a little bit more about what's behind the pipe here? What is the composition of what we call INSULPEX?
Yeah, sure. Our carrier pipe is a PExa pipe. That's important to note. That's kind of the base, product. It's the same that we use for our heating applications. The PExa pipe that we use for plumbing, for geothermal. So the core competency there is our PExa carrier pipe. And then on the outside of that is a polyurethane foam. That's a bonded polyurethane foam. It's actually bonded to the carrier pipe, to the PEX, and then in turn is also bonded to the outside of the low density jacket that is the outside corrugated jacket. That prevents the carrier pipe from moving independently. The foam and the jacket are all bonded together, so that goes a long ways towards addressing thermal expansion we'll talk about later on. And the foam itself is almost 100% waterproof. That's important because it doesn't allow wicking of moisture down the length of the carrier pipe that, as you can imagine, would offset some of the heating capability that it would have.
Great. And then the jacket, as far as putting it outside, the UV resistance is something that's important too, because a lot of these projects are going to be uncovered for a little bit. So that's nice that it's not directly onto the carrier pipe, which is something that in the PEX industry as a whole is the reason we put different types of coatings and jackets on the pipe to keep the sun off of it. So you're in good shape with the extra jacket on this product as well. So what about the different ways that you can buy it, and maybe give me an example of where a coil versus a straight length would be helpful?
Yeah, good question. So there are 10 different sizes of the carrier pipe. So it ranges, the smallest would be 25 millimeter, which is roughly 1 inch, all the way up through 160 millimeter. So 10 different carrier size options and variety of coil lengths. Sometimes it makes sense to just buy a master coil that's already bundled and pre-packaged. Sometimes that's way more pipe than's necessary for a project, so it can be cut to suit as well. So you can see a picture there on the far right with a master coil. This is a biomass project. where master coils made sense because they just used multiples of it. But sometimes you have a smaller project and it might just be a chiller pad at a hospital where you only need 50 feet of it, in which case we'll pre-cut it and send it out to suit for you.
Great. And then, so sometimes a straight length we'll get into a little bit more with photos, but where would you use a straight length?
Yeah, so sometimes the the flexibility and curvature of the pipe is ideal, but sometimes when you're trying to come in and pick up a companion flange or pick up a pump flange or something that you need the pipe to be dead straight. You don't have any any flexible or any room for flexibility. It has to be plumb and true. And so we also offer straight lengths in the 2.5 inch and above sizing. So sometimes a combination of coiled pipe for below grade, and then when we transition to the vertical, sometimes it makes sense to transition to a straight pipe at that point.
Okay, perfect. And then as you can see in the photo here, we do have some variants that have both the supply and the return in the same jacket. So that can be advantageous. So you're just running a single piece of pipe into the trench, but you get both the supply and return to a different appliance or wherever you're taking it.
And you can see there too that it's color marked on one side of it so that you're not trying to guess which was the supply and which was the return after you've run, thousands of feet of this stuff. So, it's color marked for a clear, easy visual as well.
What we used to do is my dad would just yell into one of them and I would try and hear which one he was yelling into. It's a little bit less scientific than just the the tracer tape.
Maybe better than blowing smoke at you.
Yeah, that's true. Okay, so let's go through some of the high-level different applications we have here for what we're talking about is the transfer of heated or chilled fluid. That's kind of what we would use this for, hydronics, chiller applications, and things like that. Do you want to maybe go through the list here and we can talk about a couple high-level projects that are good fits for INSULPEX?
Yeah, sure. So snow and ice melt, the first one, that's kind of the one we think of most readily. That's one that we do a lot in the Rocky Mountain states. We do a lot of this in the Canadian provinces. We do a lot of it on coast, anywhere that you have a need for snow and ice melting. So that could be ski resorts. That's easy to pick on. We've done a lot of really high profile, whether it be in Lake Tahoe or upstate New York, but then also like any federal building or anywhere that a slip and fall risk is something that needs to be mitigated. So snow and ice melt distribution piping is an area where this product is right at home. But then also district energy heating and cooling, anywhere where centralized heating and cooling to remote buildings is needed. So this could be prisons, it could be apartment complexes, remote outdoor boilers where, in certain regions that's acceptable to burn wood and use that as your heat source. Agriculturally, we've done a lot of projects with something simple as dairy farms where transporting milk was a necessity. Wineries use this product where you need to, you've got a temperature, temperature spectrum that you're working through, and you need to make sure that the wine doesn't get too warm or too cold. So this is great in places like Nampa Valley where we use a lot of this. It ties in nicely with biomass projects where you have the byproduct might be manure from cows and such, or slash from fields, and you can burn that. That's the heat source. So we've done a lot of biomass projects that ties in with agriculture. Industrial, this could be used in mining applications where it might be something as simple as keeping water for washing down equipment from freezing, or using it as a slurry to expose ore when they're mining out gold in Nevada, or applications like this. Hospitals, chiller pads are often located just out of the main pedestrian thoroughfare, and so a chiller pad that might be 150 feet away from where the distribution is going to be. So this is a great product to be able to run pre-insulated there as well. Universities, we do a lot of university work, and it could be something as small as a community college all the way up through major universities where they operate off of a central boiler kind of scheme, and then we run heated and chilled water underground. Warehouses and hangars, this is one of these kind of market segments that just continues to grow. So if you have an Amazon or a Walmart or a FedEx building that's popping up on these tilt-up buildings or in your location, this would be a great application to be able to run a pre-insulated product as opposed to steel or copper.
Yeah, and one of the things that Ginger Lewis, who's one of our marketing specialists at REHAU, is great at doing the kind of industry research, and she tuned into a Dodge Analytics, or whatever Dodge the full name is, for that group. They did a webinar and they were talking about the construction industry as it relates to COVID-19. And in 2019, warehouse square footage hit an all-time high, and it's actually projected to remain flat right now, even through a potential recession because of the virus, because of all of the people that are ordering things from Amazon and Walmart and Target, that they're actually going to be scrambling to build some additional square footage to keep up with that, even if the other sectors in construction take a bit of a dip. So that's something to keep an eye on, and we really think that there's a better way to distribute energy with this pre-insulated product. And maybe you can kind of walk us through the photo on the right there, Kevin, and explain how they're using it in that type of indoor application.
Yeah, you bet. This is for a high temp baseboard scenario. So they have this, high temp water that's going to go out to baseboards in a dormitory application here. So they have the hot, the supply and the return done up there, with a really good manifold, or with a really good fitting system. And yes, it's just going to pick up high temp heat for a baseboard setup.
Yeah, and we'll kind of talk about a few different examples where that's helpful to just kind of have it underground and out of the way, that the only thing that's sticking up for the rest of the trades to walk across or bump a truck into is just in the mechanical room or something like that. You're not trying to fight the other trades for the day of logistical space on a job site. If you can get in early and just bury everything, it's kind of a nice advantage to radiant heating too, is that we protect the stuff that we're doing, our trade is doing, by burying it in concrete, where people are going to be bumping into the sheetrock until the very last minute. So that's something that the drywallers don't have the luxury to kind of put their trade completely out of harm's way, but it's something that we can do differently with INSULPEX, and we'll kind of show some examples of that as we go through. Okay, so to start with, Kevin, what are some advantages to INSULPEX as far as thrust blocks go?
Max, what I like about the product is it really kind of simplifies things. It's simplifies the installation on the project, being able to avoid expansion loops and thrust blocks. These are two good pictures here that kind of show you what they look like. It just makes for more of an efficient installation. So when we bury this product at 24 inches or deeper, the INSULPEX is locked into place. So the slight thermal expansion that occurs it happens as a hoop stress into the foam, and not as a longitudinal stress where the length of the pipe expands and contracts with a different thermal cycling. So the picture on the left shows an expansion leg. This happens to be on a high temp steam system, and I'll show you in a couple slides the full project, but just kind of as a nice visual what an expansion leg looks like. We don't have to put an expansion leg into our systems. Granted, these are low temp, relatively low temp, 200 degrees and less, but the amount of thermal expansion that occurs is minimal, and what does occur happens hoop-wise, where the pipe grows into the foam ever so slightly, and the pipe itself doesn't grow lengthwise. And that's the expansion loop side of it. Another accessory that's needed with rigid systems is called thrust blocking. That's that picture on the right. You have to put a poured concrete block around fittings, both hot and chilled water systems, and the preventative there is you're trying to prevent fitting pullout. So you can imagine if the pipe expands and contracts, eventually it puts enough stress on a PVC or a copper or steel fitting that eventually it could fail at the fitting. And so you pour this concrete block around encasing the fitting so that doesn't happen. So a fitting system, the cold expansion fitting sleeve technology that REHAU endorses, prevents this fitting pullout from happening. So you can avoid both of these accessory items by using a pre-insulated PEX system in buried applications rather than rigid steel or copper.
And in this next slide, we'll kind of show, so this is option A will be in the black here. So just without seeing the scale, it's a little hard to read, but just conceptually, you can see all of the squares on the slide here as far as the thrust blocking, and then also these different fittings that you have to put together to get from point A to point B. So instead, kind of what we would do with a set of plans is bring our highlighter and kind of mark it up like this and say, okay, we can go from point A to point B with really minimal fitting. So we're taking all those thrust blocks out, and then we've got 2 T's here, and then a termination by this pump in the mechanical room or whatever the case is. And then on this side, we're going all the way back to the boiler or chiller plant or whatever the case is. So for 4-inch pipe, that's a pretty big deal. And that's one of the ways that we're usually able to get the attention of a design build firm if they are tasked with getting from A to B. The pink line in this slide makes it look a little bit easier than option A.
Yeah, exactly. In option A, you have a fitting every 20 to 40 feet. That anytime there's an offset or a change in elevation, you have to, incorporate a fitting where the pipe, the straight run pipe, gives you the flexibility of, literally flexibility, but also the ability to run with minimal fittings, as you say.
And just from a quality of life standpoint, we'll see in some of the slides here, it's not that much fun to work in a trench. If you can just kind of roll this pipe into place as opposed to welding steel down in the dirt and in the mud all summer or wherever you may be, that's kind of a nice quality of life improvement for the installing contractor as well.
Yeah, exactly.
Okay, so maybe walk us through these 2 job sites and kind of explain what or I guess there are a few different job sites here, but if you want to just walk us through the pictures and show us what's going on.
Yeah, you bet. So the first one, the upper left, that's at a university project in San Diego. So we have heating hot and chilled water in the same trench. It's minimal bury depth. This wasn't going to have a requirement for load rating over the top of it, but the objective here was to try to get from the central plant to the library with minimal fittings. They were working on existing utilities, so that was going to be a known obstacle to work with. And you can see this it's a good telling picture where you can see, I mean, we're on a straight line. We're able to kind of offset a 45-degree bend, and then it continues to curve around and ultimately heads towards that bank of windows in the distance. But hundreds of feet of pipe here without fittings, continual runs of pipe. And like any university project, it's time is of the essence. They don't want to have open trenches. We get that requirement quite often. We have a 2-week break between semesters or between end of school and beginning of summer school, and we need to make sure we minimize the amount of downtime on the campus, but minimize the amount of open trench for the college students to be navigating. So that was a good project in San Diego at Miramar College. The picture right below that is another college project that's at Colorado School of Mines in Golden, Colorado. That's the picture I referenced earlier, where we have a high temp steam system on the left-hand side. That's a conduit system, dual piped. So you can see what an expansion loop looks like there. That's a kind of a nice visual. And then right in that same common trench, we have our 4-inch, 110 millimeter INSULPEX, and that's for the chilled water piping. And then ultimately, both of these pick up a chase, a corridor that's just a little bit beyond that SkyTrack system. This contractor really did a great job. I mean, it never ceased to amaze how much you pick up by being on site and learning from the contractor on installation techniques. But they had a SkyTracker, and they put the forks together, ran them right through the coil of pipe, and then literally just backed the pipe down the length of the trench. They put the pipe just out of the picture below at the bottom of the screen there. They put the pipe in through a core hole that they'd cored, put the pipe in about 3 feet, so that kind of gave it some ballast, and then ran the pipe right out into a point where they could tie it into the corridor there. So really kind of ingenious. The installation went remarkably smooth. They'd budgeted weeks of time and did it in days of time, which is great. Time is money. So this is a chance to, if you're doing university work and you have to do any kind of repiping or repair piping, this is something to kind of keep in mind. And then let's see the picture on the top right, that's an agricultural project that's up in Saskatchewan, Canada. And they had lots of space, and they needed to stem the distance between barns and shops and production facilities. and they did it all with a central plant plan. And so this was heating hot water that was run out to the distance, and you can kind of see, relatively shallow trench buried in, this case, it looks like it might even be a little less than 24 inches, so it didn't need to be load rated again. But the tailings, they trench just off to the side, and then once they have this, in place, they can backfill minus any insulation or any fittings. We'll show you that later on in the presentation, but this just kind of shows you the flexibility and curvature of the pipe. It's a little bit, it's not straight as narrow to begin with, but as soon as it's backfilled and compacted, then it's locked into place. And same is true with that picture below. That's a commercial snowmelt system where they're picking up different manifold locations with pipe, and you can imagine if you had to put a fitting or an offset every 20 feet or an offset, just in the distance there, then that would really add a lot more labor to the project. And this makes for a pretty clean and easy install.
And I think that in a normal year, moving fast in some of these projects that you described is a huge advantage. I think especially in 2020, if we start to get back to business as usual with construction, at a best case, our window for construction has really been minimized. So to be able to tackle a big job like this quickly instead of spending weeks welding down in a ditch so you can get to the next job site is probably going to be a bigger advantage this year than most, just because people are going to be trying to kind of save the year and get caught up, and this really helps you move fast.
Yep, definitely.
Okay, so here are a couple pictures of the coils as we can ship them, and again, they can be cut to different lengths, and then we have basically two, an uncoiler and a recoiler, I guess you could call it, at our plant in Coleman, Alabama, where we stock a lot of this stuff, so we can coil it to a different size. And then you can see on the bottom left picture there how we band it. So we band it a bunch of different times because I guess, Kevin, do you want to explain the easiest way to install INSULPEX when you start to uncoil it at the job site?
Yeah, you bet. So it comes to you, it comes to the job site delivered like this, and then there's a system to how it's bound. Every 3 feet it's bound, and you don't want to just cut all the blue binding there and then watch it kind of open up, because then it's going to be a little tough to manage. But if you read the directions, that's kind of step one. We do a lot of field training to help guys feel comfortable with the installation. But you can see the top of the picture there. We'd start off there and open up that first 3 feet, and then the next one, working our way counterclockwise, we'd continue to follow the banding there, and it opens up. So it's a manageable amount of pipe that comes off. And like I referenced in that project, that university project, where you can take that coil now and run the expanded piece, the portion that we've unbound, and you can actually put that under rebar and stake it down, or you can put it through the foundation wall to give it some weight, and then you can just unwind it as you go. What's kind of nice about it, the way it travels, it's really easy to transport. So easy to lay down on job sites. So oftentimes when we have commercial job sites, everybody's vying for a very, very small footprint. So we have contractors that I've seen where they've actually taken the product when it's delivered and they've stacked it on top of their connexes. So where they're going to have their fitting and their tooling and their equipment they pack up and lock every day, they can actually take the pipe and put it right on top. So when you're worried about where am I going to put all this, I mean, conversely, if this was going to be a steel project and you're trying to figure out where to put 20-foot lengths of steel, it takes up a ton of space, where this can kind of be pushed off to the side of a job site, or like I said, even on top of a connex box if needed. So very small footprint required. And then once it's on the job site, you can actually transport it, fairly easy. That bottom right picture kind of shows that. These are 4-inch coils of pipe, 300 feet per coil, and they're able just to carry it with one forklift and move it from one location to another. So it gets in place, you can move it off to the side, and then when you're ready for it, you can actually stage it pretty easily.
Yeah, and there's definitely a lot of potential energy in there, so that the way that you uncoil it with the forklift like they've shown here, and some people will even do like what would you call that, like a carpet boom, where they'll put PVC over the forks, and that helps too. So it just kind of glides nice and easy on that as one way to get it off of the coil without really having to wrestle it too much. So yeah, those are big advantages. And again, up to 1,600 feet really helps reduce the fittings.
Oh yeah, exactly. And then to that, anytime that you can use mechanical equipment, it helps. If you're just trying to install this with you and a couple helpers, then that might not be ideal. It's doable. I mean, we definitely see it happen, but if you can use equipment, that makes a big difference. Yeah.
So in this job site, they solved kind of an interesting problem. Do you want to walk us through this this Foothills Rec Center application?
Yeah, this was a nice one where the requirement was we need to transport energy from this side of the two-lane road to the other, and it was actually it was waste heat from an ice skating rink that they were then able to use to heat the pool. So clever. It was a neat project. I think McKinstry was the MEP on this one, and got a chance to work alongside them and design a system that enabled them to not shut down traffic. That was kind of the objective. Just over the top of that construction barricade was a two-lane road that they insisted on keeping open. So the product lends itself nicely to directionally boring. So we can directionally drill this in place. This is a 110 millimeter pipe for for the waste heat. It was run under this two-lane road. We didn't have to impact construction at all. And this is a pretty typical application, and it's nice because you can imagine, you could have a university, grounds that the objective is, hey, you cannot take out any of these old growth, elms that are there. They're going to have to stay in place. You can't impact the root beds, but we still need to find a way to get heat from here to there. And so by directionally boring it, we can do this. And so that upper left picture, you can see this is kind of a finger cuff where it has either a threaded, male pipe thread adapter, or a finger cuff like this, and we can pull the pipe. The fact that it's bonded, the pipe bonded to the foam that's bonded to the jacket, you're not worried about pulling the pipe free of the foam and jacket. This it all pulls in one consistent pull, and it took longer to do the borehole than it actually took to pull the pipe. So in one afternoon, we had this pipe pulled, I think it was just over 100 feet in this case, but had the pipe pulled from one side of the road to the other and didn't impact traffic at all. So that was nice. We were able to keep the project moving along without shutting it down.
There's even a cameo here with Kenji Thomas looking out on the top right there with our rep in Shamrock Sales in Denver, Colorado.
Yep, yeah, go Kenji.
Okay, so this is usually kind of like the slide I showed before. We get the rigid steel drawing, and then we go back in and say, hey, you can just kind of swoop this direction with the INSULPEX instead. This was kind of a cool drawing that we actually got back from an engineer who was working on a project that they drew what they would do differently with INSULPEX. Maybe kind of walk me through both the bird's eye view and then the side view of what they were doing with the INSULPEX in this project, which it's a little hard to see the scale, but is about 58 feet from left to right.
Yep. So it's 4-inch. It's two 4-inch runs on the top for the chilled water, and then 2.5 runs on the bottom for the heating hot water. And so what the contractor in this case wanted to be able to do was run flexible pipe midway through. You can see where they have kind of those bump outs. That's a potential inline coupling. They were trying to figure out how to negotiate how to penetrate a stem wall. But in this case, they were able to run flexible pipe out without, once again, this was a college project. It was a rec center project in Los Angeles, where the design build contractor needed to be able to negotiate existing utilities, meanwhile picking up, putting 4 pipes in place and do it, as efficiently as possible. So we were able to propose that option. They didn't end up using the couplings midway down, working from right to left. So that ended up just being straight lengths of pipe without fittings in place. But the bottom picture, what it shows, we could do one of 2 ways, and they ended up using just the flexibility of the pipe and kind of over excavating a little bit, where they do the vertical transition you can see at the top right of the bottom picture. And then just with the radius bend of the pipe, they were able to account for a sweep elbow, a sweep 90 there. One thing that we proposed that would have been an option was to put in just straight lengths of pipe, leaving ourselves about 5 feet each for tails that come off. but to put in straight length pipe there and then use an elbow at the bottom of the transition, and then later insulate that elbow, and then use the coiled pipe for the remainder of the run that takes you from the right to the left, where we pick up flanges ultimately. So really made it easy to work around utilities. They had an as-built drawing they were working off of, but didn't have a lot of confidence that it was going to be up to snuff. And so this gave them the ability to, if we run into something, we'll be able to account for it, as opposed to sending it back to engineering for a redraw and new fittings to follow.
Great. Yeah. So 2 different ways to tackle that, and they've got the vertical space here to just do a big sweep.
Mm-hmm.
So one of the questions that we got in the chat, so is there any concern with keeping the pipe in the trench while it's uncoiling? Is that looking to spring back out, or is that pretty stable once you have it down?
Oh, you mentioned it earlier, Max. It definitely has memory to it. So it's funny, if you don't manage expectations, I mean, some people think, well, wow, this is just going to hop in the trench and it might even install itself, and that is that is far from the case. It's flexible and flexible in comparison to copper or steel, but it definitely has memory. So there are ways to install it that'll make life easy. So in that top picture, top left, you can see that they've actually backfilled, in the bottom of the picture, they've backfilled that portion of pipe, and that gives it some ballast, so it doesn't want to recoil. It doesn't come out of the ground. Ideally, you keep the pipe coiled, like we showed you the banding. This was a unique project, and it kind of ties in with another consideration that we like to point out. The slowest portion of the whole project is going to be excavating. So planning ahead, and in this case, if they could have, they would have done all the excavation, moved the excavated material off-site, done all of the pipe installation, and then come back at the end and brought the excavated material back to backfill it. But in this case, there was a massive mound of soil that was, the week before was at the top of that picture, and so they ran the pipe as far as they could, and then they had to stop. In hindsight, they should have been able, we should have advised, and they should have, excavated all the material first. But ideally, you keep the pipe bound as long as you can. Sometimes, situation dictates that you have to, uncut it as you go, but they could easily cut it, couple it like they did midway through there, and then add on. So that's possible. But we can tell you best case scenario when we're talking over a drafting table, but the construction project always dictates what we need to do to recover.
Sure. Just that one guy parking his truck in the wrong spot on any given day. You have to kind of adapt to it.
Yep, exactly. And then that picture in the bottom left, that's an interesting one. It's a project in Nevada where that was previously was a pre-insulated steel system. It was less than 20 years old, done with a Zeston pour-in-place installation. The steel had failed and was developing a series of pinhole leaks. And I like to point that one out. It just kind of, taking away the human, element, the human error is key on anything if we can. So this product probably would have lasted longer had the field installation been done correctly. But since since it wasn't, we dealt with a couple things. The steel requires cathodic protection just so that the pipe itself doesn't corrode. And one of the things that we point out with the polymer system is it doesn't require that. You don't have to use any kind of sacrificial anodes or any kind of cathode protection to keep the steel from prematurely corroding. But that's kind of a worst case, picture of what that looks like. But less than 20 years on a new construction project isn't that long for it to have degraded as much as it did. So when you look at the picture to the right with proper steps taken to insulate, the fittings that are required, that's a watertight connection that's not going to let water penetration come in and come in contact to the fitting. So really a well-engineered, kind of a ski boot affair, if you will, a kind of a ski boot looking insulation kit that's there on the right. So you can see kind of, the improvements that could have been made on the bottom left picture and what that looks like in a, project within the last 3 years.
Yeah, great. Those are, I feel like this picture definitely paints the long-term benefits of the PExa products pretty well.
Mm-hmm.
Okay, so let's talk about some specific projects. So this is, it's called HATS for short, the High Altitude Aviation Training Service. This is a Colorado Army National Guard project. The contractor, the installing contractor, was LD Mechanical for this job site. By all accounts, this is a very cool and strange building. Do you want to walk us through a little bit of the INSULPEX use here?
Yeah, I sure will. And this is an interesting one. Before Max and I worked together as REHAU colleagues, Max worked for a rep agency and had a chance to encounter this project with some other products to include solar and such. So to compare notes on it, we knew it from two different levels and kind of the job site requirements and some of the stuff that we had to do to respond. So funny all these years later to you know, see it from this side of it. But the INSULPEX was used in this case to supply not only the snow and ice melt, but also radiant floor heating, radiant cooling, high temp baseboard radiators. But what was neat about this is it wasn't, we were able to get in on the early stages of this with the MEP firm. And instead of running, you know, overhead piping and going up a 40-foot wall over a massive span of you know, of overhead piping and then down the other side only to pick up a manifold. We were able to work INSULPEX into the first phase of construction to pick up these manifold locations where it was trenched into place, and that just you know, speeds up the project unbelievably. So in this case we picked up a variety of hydronic applications, but it was done in a non-traditional sense. It wasn't from building to building. It was actually done within the same, you know, the same structure. And we have another one that we'll reference later on that's kind of a good way to do it. But that's just a nice way to kind of think of construction where you think, okay, I've got to do this in the third or fourth phase of construction and go up an overhead. Well, if you kind of do a little paradigm shift and think about picking up your distribution piping earlier under construction, there's less trades in the way and it's a lot easier to schedule.
And this job site, so when this building was completed, the use case is it's a hangar that different branches of the military, I believe from all over the world, different allies of ours will come and do training at the high altitude because they can fly around in Eagle, Colorado. Gypsum, Colorado is where this is located, right at the airport, actually, the airport that you can fly commercial planes into. It's on the other side of the runway there. But what it looks like is this enormous hangar that one entire wall opens up so you can bring in all sorts of huge airplanes and helicopters and things, but it's like a shiny white polished, almost looks like you could eat off of it, clean surface that they bring all of these planes in and work on them and things like that. So what's cool about it is there's just not any mechanical equipment in the way of doing this, because if you can imagine, it would probably be a bad day if you pulled the whatever Apache helicopter into some sort of fan coil unit that's dangling from the ceiling, or bump the tail of something into steel pipe that's hanging to go to the other side of the building. So they were really able to solve a lot of problems here. It's actually radiantly heated and radiantly cooled, which is weird for a hangar, because that whole door opens, but because the load is so low and the air is so dry at this elevation in Colorado, it made for a very interesting project from a hydronic standpoint, and really solved a lot of problems for them. So they weren't worried about backing into things that would cause a lot of damage. Probably the heating system would be the least of their worries if it was a big F-35 or something like that was damaged. So kind of a cool project for a variety of reasons, and was, yeah, a fun one to visit. One of the times that I went there, I was wearing dress shoes and was trying to look professional, and I see the guy who's going to let me into the front door because it's obviously a very secure facility, and he sees me walking across the parking lot, and I step off of the curb and both of my shoes came out in the mud. So probably right where like that lift is on the left side of the photo, I stepped out of both of my shoes and then went just like ankle deep into the mud as everybody's like watching me, waiting for me to like come look at something. And they're like, oh yeah, this guy's gonna help us out today. So that was one of my embarrassing moments as a manufacturer's rep wearing dress shoes.
You didn't tell me that, Max. That's awesome.
Yeah.
Oh boy.
So yeah, I know what that dirt feels like specifically. Okay, so this is a new project for us. This is actually not open yet. So it was scheduled to open at some point this summer. The building itself is finished. They're moving the stuff into it now. So this is the Museum of the Army, and it's in Virginia. So eventually this is going to have all sorts of cool stuff as far as, you know, planes and tanks and historic documents and things like that. This is radiantly heated and radiantly cooled as well. Similar process, they didn't want to have overhead piping. So they've got 24 different manifolds scattered throughout this building to do the heating and cooling. And they feed it with the INSULPEX that was buried beforehand. A little bit different use case, but similar, that you don't want a steel piping distribution line to drip on top of you know, whatever documents and things that cannot be replaced. I imagine a tank can get wet, but probably not some, you know, very historic Army document that they've got in a glass case or something like that. So this was a cool project by Southland was the MEP firm, Clark Construction Group was the GC, and then Skidmore, Owings and Merrill are the architects. So I'm excited to go visit this. It's not open yet, but apparently the mechanical system is up and running, and they're just kind of getting everything staged. So hopefully we can go see that later this summer. But yeah, very, very cool project. And again, uncluttered vertical space definitely with this one. Okay, so this is another project that I think has a lot of benefits to different types of systems. Do you want to kind of tell us what they were doing with this job site?
Yeah, you bet. We early on talked about different applications, and district energy is one of them that we promote the product for. So this is kind of a great case in point. This is a federal penitentiary in Nevada, and so the objective was, okay, we've got an existing penitentiary that we're not going to idle and move inmates. They need to stay in place, but we need to be in and out as quickly as possible. We want to minimize the amount of time that the trenches are open. We need to bring all the mechanical into a central location so it can't be interfered with. There's no open chases or ducts, for potential inmate escape, things like this. So the objective was we need to be able to run heating hot water, chilled water, domestic water, all in a common trench and pick up, multiple buildings. This ended up being kind of a pretty big in scale project, but you can see the pipe there. I mean, it goes out quite some distance. They could have run this and stacked the pipe and dug deeper in the trench if they needed. They chose to space the piping out, and it's really well done, well installed. The picture on the left shows the mechanical connection that's used, where we use a sleeve cold expansion technology. So when we put the fitting in place and then insulate it, they do slightly a different insulation strategy on this system than one of the pictures you saw earlier. We have a couple to offer. But they were able to meet the needs of the state. Quick in and out project that would have taken a year to do with steel. We were able to do it in weeks with pre-insulated PEX. And it was also working around weather schedules and things like this. So miles of pipe done in a relatively short amount of time, but ultimately protecting inmate safety and making sure that we didn't have any flight risk, I guess, at the same time.
And then you had mentioned too that for the contractors to come to work here every day, it's a little bit of logistical difficulty to get your tools and all your stuff, on that side of the fence. So to be able to reduce the amount of days on the job site, that's a big advantage.
Yep, for sure. Yep, no flame, no open torch, things like this. And then yeah, not a lot of equipment in general. And what there was easy to come in and out. But I guess the logistics of getting in and out was quite a process in the morning and the evening checking out.
Yeah, I bet. So one of the questions on the bottom left slide, what's the smooth wall pipe in the middle? So that's one of the other insulation kits to cover the fitting there, so it's not exposed. But the actual carrier pipe is that corrugated looking material. So the district energy applications, I think, presented by this particular job site are interesting on a bigger scale. I mean, in Europe, they do a lot of different district heating. in big cities in the US, they do district heating. You know, some of those systems are still big district steam in New York City. In Denver, they had a lot of district steam, things like that. In Europe, they do that all the time with hydronics as well. It's something that hasn't really caught on over here to the same extent. And I think that it's a nice problem-solving way to approach a big project like this. I mean, it can be a campus where if someone's paying the bill, the energy bill for a few different buildings in a cluster, there's some huge advantages to just having the boiler and the chiller out of the way, not under, you know, the roof of the occupied space where people are going to be working in offices or maybe living. If you can get that equipment outside into the parking lot, have a little, you know, boiler house that you can back a service truck up to and work on, do your clean and check without having to get into a single unit, disrupt the residents and things like that. It really is a big problem solver if you start early in a project and say, okay, instead of putting a single boiler in every one of these 10 units, can we do 4 bigger boilers out in the yard somewhere and then just run the pipe to each of the units? So it's really something that I think the, you know, design build engineering firms of the world are catching on to this. This particular project with the prison had some additional benefits to not being on the job site so long, but really there's a lot of benefit to not disrupting people to do the service and maintenance for the lifetime of the system. If all of the mechanical equipment's kind of out of harm's way, then you don't have people tampering with it or breaking it, or, you know, storing the vacuum in front of it and knocking something over, or playing with the boiler settings or whatever people do when the equipment is in the space that they could otherwise use for, you know, additional closet space or storage or something like that, because occupied space is definitely such a premium. If we can get the mechanical space, which is really to the end user wasted space in a lot of ways, the average building occupant doesn't really appreciate the boiler in the basement. They'd rather have that space for something else, to put a ping pong table down there or whatever. So I think that that's starting to catch on a little bit more, but I think that INSULPEX can really help you get to that end result to distribute energy better. One of the things that we didn't mention but usually comes up is R value. So it's kind of a complicated question. Do you want to walk us through the R value conversation that we have with INSULPEX?
Yeah, it's not as straightforward as R value like for board insulation. So when we talk about insulation needed below, say, a snowmelt system, it's easy to say, you know, a 2-inch high density has an R value of roughly 10. With circular product, it's a little tougher to quantify an R value. So we kind of change the conversation to K values and then thermal efficiency. So if we have, you know, if we have a demand, we know what our load is, we know what our supply temp needs to be, and then what our acceptable return temps are. We can run those calculations for you with a product like this. If it's just a straight up, I need to know, is this an R value of, we can throw round numbers out, but an R value of a circular product's not quite as clear and easy to identify as a board, you know, board R value is.
Great. And as far as areas for growth for you, where do you see a lot of potential for pre-insulated pipe like this?
You know, the feedback that we get, and we see it an awful lot, you know, on the design build side of things, where a contractor will, you know, bid a project, and it could be a UPS distribution facility, it could be, you know, just a basic warehouse. But instead of going up and over inside a building like we talked about, I mean, our plant in Coleman, Alabama, you don't think of, you know, Coleman, Alabama is getting cold, but we actually have all, you know, all the remote manifolds are carried with the INSULPEX product and done, you know, below ground. So the areas that we've been able to help design build mechanicals, they win a project and have planned on doing, you know, type L copper overhead and using scissor lifts and you know, doing it kind of in the latter portions of construction. When we propose this, or when they kind of start thinking about this way as their distribution you know, system, then it's so much quicker. They're able to get in and out of the project a lot faster. So I'd say, to your question, Max, I'd say inside the building, kind of be open and receptive to running your distribution, your hydronic mains underground, as opposed to just thinking about this as it's typical district energy where it goes from building to building. It can be equally, if not more effective, done inside a building.
Yeah, and I think that we kind of alluded to it before, but instead of fighting the electrician and the HVAC guy and the telecommunications people for the same space on the scissor lift to get up above a big warehouse or something like that, you can just be done. You could just have from A to B out of the way, and you have your supply and return stubbed up in 2 different locations, and then you can let the rest of the trades kind of fight for the space above head, because it's never that much fun to have to coordinate that much more than you need to. So definitely a way to solve some problems there too, to just prevent the problem from coming up.
Mm-hmm.
So one of the things that I wanted to do too in the last couple minutes here is open up the website, and I'll kind of show you where you can see more information about INSULPEX. So this is on our na.rehau.com, and then I just went to Technologies Pre-insulated PExa piping. So we've got more information about more in-depth stuff about case studies. Here's an insulation kit, the fittings that we use, different applications, sim, snow and ice melt, things like that. You can read more about the project profiles here. And then I'm going to go to our resource center too for INSULPEX. Then I'm going to do mechanical and plumbing. And then got a question as far as, and I'll see if I can just find it as we're going through here, Kevin, that was typed in: max temperature and pressure for the product.
I can tell you as you're looking for it there,
Sure.
but it'd be good to point it out as well. So just kind of for some round numbers, I mean, 132 PSI at ambient, so that's 132 at roughly 73 degrees F. And that's on the high end. The other end of the spectrum, 58 PSI at 200 F. So these are going to be, considered low temp hydronic systems, 200 kind of being our cap. We try to, if at all possible, design these systems at kind of a happy medium of 180 degrees for the fluid temperature. And in doing so, then you have 66 PSI is kind of, those two go hand in hand, 180 degrees Fahrenheit at 66 degrees for the pressure. Obviously there's a correlation there, but if we can run these systems slightly cooler, they're not meant to be steam or condensate systems. These are going to be hydronics, so whether it be heating hot water or chilled water, but that's kind of the round numbers to work within.
Yep, and one of the big advantages with hydronics too is that a lot of the projects that we're working on with radiant heating and radiant cooling are staying really low on the temperature range there, that we don't need 180 degree Fahrenheit, also because we're not losing so much temperature. So if you were if you needed 140 degree Fahrenheit water at the end of a 500-foot trench, you might have to supply something a lot warmer if you're doing it with a different type of product. But with the pre-insulated PEX, we don't have to shoot that much higher because we're not losing as much in the trench. So a couple other questions that are coming in are asking about potable water. So for a different division of our company, they have MuniciPEX, municipal piping, that we do pre-insulated pipe there too. So that would be from the municipality to the curb to the actual building, that we do with pre-insulated pipe in a similar setup, just with the certifications that you would need for AWWA and those things. So not O2 barrier pipe, it would be for municipality use. So that's a different kind of sister products to the INSULPEX that we'd use for heating and cooling only. Okay, then let's see, what else do I have for questions here? So that is the majority of the questions we've got. As far as the polyurethane foam breaking down, so is that something that you've noticed, or what's to be expected there?
Yeah, so it's a pentane blown polyurethane foam, and so there is some element. It's called outgassing, and so the the gas leaves the polyurethane foam over a prolonged amount of time. There's an equation that you can run that gives you an idea of how much degradation there is over time. This system's closed in the sense that we don't see a lot of that. We have projects that we've started, and 15 years later we're adding on to, and the foam, aside from being a little yellowed, it's still it still is intact. It's not like it turns to powder and is non-existent like you'll see in some other alternative systems. But yes, you do see some outgassing. You do see some you do see a little bit of that insulation value over time go away, and that's going to be true with any pre-insulated, whether it be copper or steel, but it's very minimal with this product.
Great. And then one of the questions is about steam systems. So we would shy away from actual steam distribution with these systems, like we showed for, I don't know if it's this picture up here. They actually ran a separate line for steam that was steel. We would prefer to just do the hot or warm and cool water. It's not really best utilized for steam, so we would avoid those types of projects.
Yeah, typically steam, water flashes to steam depending on your elevation, somewhere at like 204, and we're endorsing these systems for 200 and below, and ideally for 180 is kind of the happy spot. So this would not replace a steel system for steam. This is for a hydronic system.
Yep. Okay, let's see. So that looks like it is about all of the questions that we've got typed in here. We've got a couple others that we can follow up with after the fact to shoot over specific documents and things like that. But that's all I had for the presentation. So you can always find more about this product on our website, na.rehau.com, and then you can do na.rehau.com/INSULPEX. Will take you right to this page. Let's see, I've got one more question coming in here. As far as different fluids go, like a pentane or something like that, we would shy away from those types of projects as well. We're talking about mostly just water and a water and glycol mixture. Have you ever seen any other creative uses that people have used for these systems, Kevin?
Milk was kind of odd just because it was acidic, but we've seen a variety of different ones. The quick answer is if you have something that sounds obscure, if it's some kind of motor oil, if it's some kind of DIY, water, if you come across different applications and you're curious, I mean, I've learned a ton in this question and answer, over the years. Contact your local REHAU rep or your local manufacturer's rep for REHAU. With an MSDS of what you're trying to transport, we can pretty quickly get you some answers on what we're capable of. And what it is just making sure that it wouldn't have a negative impact on the pipe. Typically not. The fitting systems, we just want to make sure that we endorse it for the right application. But we've done some interesting stuff over the years, and it's always kind of a learning curve. But the easy one is glycol fluid for heating systems, or just traditional water systems for chilled water. But yeah, we've done some interesting things over the years too. So test us a little bit and see what you have we can help you with.
Great. Yeah, it looks like the last question I've got is, where do you think this business is developing in the future? I think that we've kind of mentioned for the second half of 2020, I would think that warehouses and people that are on a very crunched installation timeline, and maybe it's not even these district energy projects as much as it is just you have to get from one side of the warehouse to the other, and if it's going to take you 4 weeks to do that with steel, and you can do it in a handful of days with the pre-insulated pipe, hopefully we are able to kind of snag some more of those projects and solve some problems for contractors who are trying to get off the job site and get on to the next one before it gets cold again, because we know that this is going to be a fast summer. So yeah, that would be kind of a summary answer to this presentation. Do you have anything else to add, Kevin, before we wrap it up?
You know, I'd add one more that's kind of a growth area. We don't do lots of them, but the ones we've done have been pretty impressive. Is like campus geothermal piping, where you run a geothermal borehole field into a common manifold location, and then run this product to and from the remote manifold. These are big manifolds, like walk into concrete, poured in place kind of affairs. So you know, if that's an area that you're active as an MEP or a design build, that's an area to think of too, where, you know, at that point, we're a little more conscientious of the temperature variation or the thermal, you know, the temperature swing there. So this is an area that we can help you as well.
And this is kind of an example of that type of project too. This whole quad at Arcadia University is a bunch of vertical geo water to water wells. And then there's a big pit here that they're going to take all of the supply and return for the whole field back into the building. So that would be a great application for INSULPEX as well. And again, in this campus setup, you could even have it go to different buildings as close as these are scattered together. You could take that geofield to a lot of different places. This one wasn't an INSULPEX job. This was a REHAU Geo, which is our water-to-water geo exchange product. But this whole community is geo with like a big loop around, and they're taking the water from the vertical wells for this geo system to each of these houses. So it's a big district energy system, but for single family residential. And then they're going to water to air heat pump, and then, you know, blowing the warmer, cool air around the different residences. This is in Austin, Texas. This community is planned to be 7,500 total homes. So that's another kind of cool district example, but with a residential spin, which is a little bit different than the hospital or university campus.
Mm-hmm. Yep, good point.
Cool. Well, that takes us 2 minutes past the hour, so we'll go ahead and wrap it up here. I'll stay on the line for a couple more minutes if you have any other questions, and then we'll follow up with some of the questions that were typed in with emails as that's appropriate. But Kevin, again, thank you. Thanks for giving us a tour of these INSULPEX projects, and yeah, thanks for being my guest.
Oh, you bet. That was fun. Thanks, Max.
Thanks.